Hi everyone and welcome to this new video. In this video we continue the Active Directory exploitation series. Specifically in this video we talk about pivoting and lateral movement. Now as always, I hope this video is useful, I hope you get something out of it. If you want to support my work, you can subscribe to the channel, you can share these videos with like-minded people, and there is also a Patreon that contains all these notes and examples. Thank you very much and enjoy the video. So before showing a practical example of pivoting, because the best way to teach is just to showcase how something works, let's discuss in general, okay, what is pivoting? What it is that we are referring when we speak about pivoting. So pivoting is a technique. It is a technique used during penetration tests or during malicious attacks, and it is used to perform a thing called lateral movement. Now, you can perform lateral movement over a system once you have compromised an initial portion of the network, so you have access to one or more machines in the network and you won't compromise it further. Because of course, an initial access does not mean that you own all the machines in the network. There could be some internal machines that you still have to access. And so with an initial access, you can do lateral movement through pivoting to compromise the entire network. Now consider let's put this discussion now in the context of Active Directory. Now consider that pivoting is a general technique, does not have to do only with Active Directory. However, it is often used in the context of Active Directory. And why is that? Why is it that in Active Directory this technique is often used? Well, it is because in Active Directory we have the domain controller, which most often than not is not facing publicly accessible interfaces. So what does it mean? It means that now in the lab that we are using for the course, we have a very simple setup made of a DC, a domain controller, and a simple workstation, right? And then we have our Linux host, which can actually access directly both of these machines. So from the Linux, I can ping the IP of the domain controller and the IP of the workstation, and also domain controller and workstation can also communicate. Okay. Now this actually does not really happen in real life. In a production radio environment, this should not happen. Why? Because there is no need to expose a domain controller to external hosts such as our Linux, which simulates the attacker machine. The domain controller is only useful to the internal workstations and servers of the Active Directory network. Therefore, it should not be easy to access it. It should not be direct access with the outside world. So basically what happens is that we have complex networks in the real world where the domain controllers, to reach them, you need to pivot through different machines. And here I have a diagram that showcases this behavior. Now in this diagram you can see a very simple randomly generated AD network. Like the most important thing is not the specific topology, it's just to showcase the basic idea. So here we have a network made up of various elements, some workstation, some servers, and two domain controllers, DC01 and DC1 and DC2. Then we have the public internet with all the hosts we can find on the public internet, and here I just highlighted two Linux machines. We can think of them as like the attacker box or just a client machine that uses Linux. Now, as you can see, the Linux machines cannot directly access the domain controllers. They do not have direct connectivity over the domain controller. Rather, they can access different workstations and different servers for different purposes. And it is those servers and workstations that then access the domain controller for the AD part of the network. Now, this means that there are certain machines which act as a pivot point. And they act as pivot point because in their configuration, they have access to multiple network interfaces. They have multiple network cards. Some of the time this is physical cards, so physical connectivity. Other times we're talking about virtual cards in a virtual environment, but the idea is the same. They have access to multiple interfaces. In this situation, in order to attack the domain, ultimately we need to compromise a domain admin and we need to get access to a domain controller. And to do this, we need to use these middle servers or workstation as pivot point. We use them to route our traffic. We will execute some command in here which create a tunnel from the Linux box to the various domain controllers. And these tunnels, they use these points as the way to actually communicate. So in these situations, in order to attack the internal domain controller, it is necessary to use intermediate servers and workstation as pivot points. They are useful because they allow the attacker to access more networks. And consider this example. So how do we know if a machine has access to one or more networks? Well, we can simply use the ipconfig command once we have access to the machine. Because remember, this technique, pivoting, is used after an initial compromise. We must be able to execute command on that system. Only then we are able to use that as a pivot point. So consider this machine. Here I'm executing the ipconfig command, and here I have two different adapters, Ethernet adapters. One is for an external facing network, the other is for an internal facing network. So in this case, I have IP address 192.168.122.105. This is for publicly accessible network, so everyone in the internet can access that endpoint. Actually, this is not a public IP, but it's just, we're just discussing, like, this is exposed to the system. Now, specifically, this is exposed to the QEMU, to the basic QEMU NAT interface, so I can access it from my Linux host. Now, this other instead is an internal network that was created between the domain controller and the workstation. This means that the Linux cannot actually see this network, cannot actually connect to the host in this network. And so basically that's the idea. Now, how did I generate this? By the way, through Emacs and org-mod. Here you can see this is a graphics file, graphviz file. This is a graphviz file. And here I have the syntax and I can generate this. But this is just a little parenthesis that is really cool and I just wanted to showcase. So that's what is pivoting. Now, let's see a practical example. Because with pivoting, to be honest, there's not much conceptual thing about it, it's just you gotta get used to the practical commands. So let's see a practical example. Let's analyze this scenario which I've recreated in our laboratory. And for those of you interested in doing the same, I will put a section here, scenario setup with QEMU, in which I show step by step how to configure it in the QEMU environment that we created. This is going to be available for the Patreon subscriber. Now, for the sake of the video, however, I will not go into the details of configuration because ultimately they do not matter for the technique itself. The technique works regardless of how you configure it. I just showcase the way to do it if you use QEMU. So let's say we have an Active Directory laboratory with two machines, a domain controller and a workstation. And these are the data, the network configuration for these machines. So the domain controller listens on a single internal network interface. It's called internal network, and it has this particular subnet, 192.168.1.105.0/24. So this is like a very simple subnet, and this is the specific address for the domain controller, 105.30. Then we have the workstation. Now the workstation is connected to the internal network, which means that it is connected to the domain controller through the same subnet, so they share this subnet. It means that in this network we have domain controller and workstation, but it is also connected to an external network, which has this different subnet, 192.168.122.0/24. So they're both /24 subnets. Now, I will not talk about the theory of networking of subnetting. Maybe in the future I can make something like that. If you're interested, let me know, write in the comments. However, what's important to know is that these are the two IPs for the workstation. So .100 for the internal network and .105 for the external network. Now, the external network is also connected to our Linux machine. So we can ping this machine from the outside, from the Linux box, but we cannot ping the domain. And this is a really important key point. And we can visualize this as follows. So we have the workstation, we have the domain controller, and we have our Linux machine. Now, workstation and Linux machine are connected through this subnet, while workstation and domain controller are connected through this other subnet. And thanks to pivoting, we will be able to connect to the domain controller, we will be able to access the domain controller and to enumerate and attack the domain controller through the workstation. So we use the workstation as a pivot point in order to create the illusion of a direct connection, while in reality it is not really direct, it goes through this pivot point, through the workstation. Now let's simulate that we have compromised this workstation, right? So we can execute code in this workstation. Now here I'm showing on the graphical interface, but you can imagine that here we have a reverse shell, maybe we don't have the graphical interface, but we have a reverse shell and we run the command ipconfig, and here we see, oh look, I have two different network interfaces, right? I have this one, the 192.168.122.105, which is shared with my Linux box, because if I go back to my Linux box here, and I just do EPA, here I have a bunch of different interfaces, right? But among them, I also find this one, verb 0, this one, 192.168.122.1, and here I can access, using this interface, I can pretty much access this workstation. And how do I know that? Well, we will see, because we will have to download some files. So I will show that direct connectivity. Now on this workstation, however, I'm also connected to a different network interface, which is this network adapter Ethernet 2. Now here I have a different IP address, which is the .100.105.100. And the domain controller instead has, as we were saying before, it has this IP address, the .30. So let's ping it to make sure that we can reach it from the workstation. We're gonna ping it, and notice that it replies. So it's replying, and so basically we can connect to the domain controller. However, from the Linux host, if we ping the same thing from the Linux host here, it's not gonna find the route. It cannot find the route, therefore it cannot ping the domain controller. We have no direct access over the domain controller. So this is used to simulate a scenario in which we are forced to do pivoting in order to reach the domain controller. So that's the idea. Now, how do we actually do it, right? Well, it's actually pretty simple. So let's assume we have compromised the workstation and now we want to access the domain controller. Since we cannot ping it directly, we must use the workstation as an intermediate pivot point. Now, for doing this, there are a bunch of different tools. However, the one that I use when I have to do these things is called chisel. Now, on this, I don't know if you have different taste. If you think that some other tools is better, write in the comments. Here I'm gonna showcase the idea. Now, different tools have a slightly different like a command lines option and things of the sort. However, the basic idea is the same, and with chisel you can definitely use it, for example, for OSCP. That's what I use in my OSCP exam. I used chisel and it was fine. Because, by the way, I did not mention this when I was explaining pivoting, but for example, when you're doing OSCP, you need this technique, because in the OSCP ID network, when you're doing OSCP, the ID network is made of server 1, server 2, and DC01, and you can only access one of these machines. So you have to go through one of these machines, and then you have to pivot between the DC01 and the S2 and the other server. Basically, that is the idea. They are called MS01, MS02, and DC01, but the name is not important. It's just that you actually need this technique, otherwise you would not be able to access the domain controller. So that's it. Now, how do we use chisel, and what is, by the way, chisel? Now, chisel is a tool that allows us to create TCP and UDP tunnels over HTTP. So over the HTTP protocol. It means that typically what we have is we have IP, we have TCP, and then we have HTTP. While with chisel, we can do that to wrap another TCP connection. And on top of the TCP, we can put any protocol we want. So all of this goes inside the HTTP message. So basically, that is the idea. Now, chisel is not the only tool we will use, because to then proxy all our commands to the tunnel that was created by chisel, we will actually use proxychains. And proxychain is a very useful command that takes any other command and it executes that command in the context of a particular proxy. It proxies the traffic generated by a command to go through a particular proxy. In this case, it's gonna bring the traffic to go through chisel, which will bring it to go towards the domain controller. So basically that's the idea. So let's see the setup. Now I'm gonna show a setup that is based on Docker. I find this very useful because basically it means that you don't need to install a chisel. You only need to install proxychains. So that removes one dependency. So we can use the Docker image. This was taken directly from the chisel repository, basically. So we can run this, and I've already downloaded the image, and this is the help menu. So first thing is we need to download the chisel executable in our machine. Now this executable is actually the executable that will be executed on the workstation, and it's going to be a client version of chisel. So we're going to do this. We're going to wget this from the GitHub. So I've tested these commands and they work. So you wget this, you gzip it, so you remove the compression, and then here I just like to rename it from the chisel version whatever to chisel.executable.exe. Now if you analyze the file that we've just downloaded, this is a PA32 executable. So it is a 32-bit executable for Windows, so it works on Windows. Typically Windows is compatible with 32-bit, so it can work. You can also download the 60-bit version, I believe. I don't remember the name. However, both of these versions work. And for our purposes, there's no really big difference, as long as it executes on the machines that you're running. So that's the idea. So the process works in 3 steps. Actually, not in 3 steps, in the following steps. There are a little bit more, there are 4. First, we're going to create a Python server. Then we're going to download the executable on the remote machine. And for this step, of course, we need a direct network access to the workstation and in general to the pivot point. It means that from Linux, we have to access the pivot point. Now, once we have that, we can use that to access more networks, to access more machines. So first we need this. Then from Linux, we start chisel in server mode. So we say server and we say reverse. And here we put the port that we are listening for incoming connection. And look at this, here I have to put the network host flag actually. So this port really does not matter because ultimately I'm gonna just share all the same ports with my host. This is because chisel actually opens 2 ports. The port 80 for listening and the port I believe 1080 for the proxy itself, for the communication itself. So the port 8000 is for listening for incoming connection and the port 1080 is for the connection traffic itself. So from Linux we will start chisel. Then from Windows, after we have downloaded chisel, we can connect as clients and we can say r/sox to create a proxy using the SOX protocol. And then once we have this setup going, we can use proxychains with any command, and this command will actually be executed on the server, which means that now this IP address will become actually reachable because we don't reach it from our Linux host, but from our Windows intermediate pivot point. So let's actually do it. Let's create, so here I have the chisel executable. So as you can see here, I'm going to create a Python server and I'm going to download it from the workstation. I'm going to ask from the workstation to this web server, I'm going to ask, can you give me the file chisel.exe? Good. So let's do this. So let me copy it better. We're going to use certutil as a means to download file. I mean, you can use any file download utility, basically. So that's the idea. And now the command is completed successfully. Perfect. So we have this. And now we have chisel.exe. Perfect. So after we downloaded the file in Linux, we can start chisel using the Docker. So we do this. Notice that here I've put network host. It means that all the ports that will be open within the Docker are also going to be open within the host. So there are not going to be network problems. Now we can also remove that and you can put a specific port mapping. Like for example, here I can say 8080, 8080, and then I think I have to put 1080, 1080. At least these 2 ports are needed. I'm not sure if there are needed more, I don't remember. If you put network host, however, you're going to solve this problem. Of course, there are other considerations to do, but it's just to showcase the basic functionality. If you need it for an exam, for a few hours, you can simply use this solution. It is the most straightforward one, to be honest. So that's the idea. We start Docker from Linux. This is important. We start the server mode from Linux. Now, from Windows, we're going to connect to this server and we're going to start the proxy itself. So here, the critical point is that here I've used the IP of my Linux that is reachable from the workstation, here with the port of the web server 1337. This is just to download the file. I mean, you can download the file in other means, whatever. Then here, it's really critical that I put the address where the chisel is listening and the port where chisel is listening. Now, by default, if I just launch it, here I get port 8080. So that's the port I get. And then we put reverse SOX, r/sox. So basically that's the idea. We execute this command in the context of Windows. Now here, I've downloaded the file, I'm on PowerShell. To execute the executable, we can just drop into CMD, so that we can just copy paste the command. We do this, and notice it connected using WebSocket to our endpoint with the port 8080. Now we have a session, and this session establish a proxy that can be used to like pivot into the internal networks of the network. And here this proxy is listening to 127.0.0.1.10.80. It means that now in my Linux box, if I do netstat and I grep for 1080, I get this line, and this line appears when the proxy was successfully created. Now, if I want to use this pivot, the workstation as pivot point now, I have to route my traffic to go through this particular proxy. And how do we do that? With proxy chains. And here I showed a very simple command which will actually execute an SMB map over the domain controller. Now this I showed in the attacks on SMB, on the SMB protocol. There in that video I showed a bunch of different commands. Now, since we cannot connect directly to the domain controller, technically we cannot execute directly those commands. However, with proxy chains we can once again, because the traffic is routed through proxy chains. Now, one change that I made with respect to the default proxy chains configuration is that if I cut the proxy chain configuration, at the end here I have this SOX5 127.0.0.1.10.80. So before there was SOX4, I wrote SOX5. I'm not sure if this is a requirement, however, if you have problem, just change that to SOX5 and it should work. Now, how do we use it proxy chains? Well, it's extremely simple. You just append it before the command and then you write the command as it were before. So let's download quickly SMB map. So here I have a simple Python environment. I'm gonna download SMB map. So let me download SMB map. And let's try to execute the whoami command going through proxy chain. Here, of course, I have the credentials for the administrator, but I showed them in the previous video. They are simple credentials. So this is going to be the final test. So let's see proxy chains. Notice what's gonna happen. So of course, it took a while. It's gonna be slower because you have to go through the proxy. But basically, it detected the host by going through this proxy chain. So look at this, it says, I go first through this and then through that. So there is a one hop now. I don't access the domain controller directly, I go through this one hop intermediate. Now this makes everything a bit slower, so it can be very slow. But here I have my commands, xdump administrator, and here of course I can put any command that I want. Of course, it's gonna be slower, it's gonna have performance issues because I'm proxying the traffic. This is gonna be as low as the number of pivot points that I have. Also, the commands can break because maybe they don't receive a reply in time. But basically, it is as simple as this. Especially when you have simple setups with few machines and few pivot points, you can use these like 4 steps. You create a server, you download the executable on the remote machine, you start it on your machine, and then you start it from Windows. And once you've done that, you have connected this machine. Then, if you go to another machine, you can repeat the same process. And by going through this pivot point, this means that you can access further pivot points. You can access, like for example, let's say that this DC2 was only accessible through DC1. Then first you will need to like get access to DC1, and then you would do the same thing, but this time going through this pivot point to get to DC2. Of course, the more pivot points you have, the slower it becomes, the more unstable it can become because you have a lot of overhead, basically. But the general idea is the same. And so this is it for this video. In this video, I talk about pivoting and lateral movement, and I showed a practical example with the chisel and proxy chains on how you can set it up on your own. If you want to support my work, you can subscribe to the channel, you can share these videos and this series with like-minded people, and there's also a Patreon which contains all these notes. Thank you very much, and to the next video.